Welcome back to another Spectacular thing. Today we are going to build an e-reader out of an e-paper module and a Raspberry Pi 4. As you can see here, we have a 5.65-inch e-paper module, which also displays 7 colors. And we have a Raspberry Pi 4, the 4 gigabyte version, and we have 2 buttons, so we can press to the next page and we can quit the app. Let's go ahead and look at how we can do this. For this project, we need to install some software. So sudo apt install. We want to make sure Python 3 is installed. We want to make sure that Python 3 pip is installed. And then there's some other options that we need to include. Python 3 pil, Python 3 numpy, numpy, Poplar utils, as well as rpi.gpio. And this will take just a minute to install. Okay, now that those have been installed, let's install some pip. Let's install some Python stuff. So we say pip install PDF to image and pip install SPI dev. Pip 3 install. Okay. Now let's create a directory for our project. The -p option includes any parents that need to be created. Then let's change to that directory and create another couple of directories. We want to create a lib folder with Waveshare, EPD, and then we're going to create a folder for the PDF that we're going to put on the screen. Next, let's open this up in code, Visual Studio Code. To do that, in Visual Studio Code, make sure that you have Remote SSH extension installed. This gives you this green button at the bottom left-hand corner. Click it and say Remote SSH connect current window to host. And then name the host, which I've already done here. Give the password, and it will connect to the host and install Visual Studio Code Server on the host. Then open up Explorer and click the Open Folder button. Click Projects and e-reader, and then say OK. And a new window will open up that you need to sign in with. Now let's copy a couple of files into this Waveshare EPD folder. These 2 files are found on the Waveshare site and are packages to help us communicate with the EPD, with the electronic paper display. This first one is 5.65 inch FPY which you'll notice on the module 5.65 inch ePaper module F. And then the EPD config as well. Then under PDF, we want to copy our PDF file. To do that, let's secure copy our PDF over using SCP Raspberry Pi Handbook 2021 Digital V2 PDF. It's kind of a mouthful. And we want to copy that to pi@ashley. And we want to move that to the following directory. eReader/PDF. Type in the password, and the file will be copied over. So there's two ways to copy files to your Raspberry Pi. You can either drag them over into Visual Studio Code, or you can do SCP to copy them over. Next, let's create our file for our project. Before we begin writing our project, there's a couple of extensions that we want to install inside of our Raspberry Pi to make life easy on us. So the first thing we want to do is install Python. Click the green Install in SSH, and this will install it locally on the Raspberry Pi. Then we also want to install Pylance, and we also want this to be install in SSH. Once that has been installed, let's reload the window to activate. And enter your password. Make our terminal a little smaller so we have room to type up here. Next, let's write our code. There's three things that need to happen. The first, we need to initialize the images. Then we want to display a page. And finally, we want to wait for input from our two buttons. So the first thing we need to do is we need to import PDF to image. And we want to import convert from path. Then we want to import sys as well as OS. Then we're going to create a libdir. Which is equal to the OS path join of OS path dot dir name, the directory name of the real path of the current file. And we want to add in, we want to join that with lib. That's for our lib directory. Now, if the path exists, then append it to the sys. Then we can say from waveshare EPD import EPD 5-inch 65F. And we can ignore this little warning here that it could not be resolved by Pylance. Next, we're going to import logging as well as time. We're going to import rpi.gpio as GPIO so we can have access to these the GPI port here for the buttons. Then from PIL, we're going to import image with a capital I, excuse me. And last but not least, we're going to import temp file. Next, let's configure logging. And we're going to initialize a variable called page number. And we're going to default this to page 0. We're going to store all of our pages in the PDF as images in an array. So the page number starts with 0 because an array is 0 based. So the first thing we want to do is we want to define a function. Let me roll this out of the way. We're going to define a function called initImages. And what we're going to do in here is we're going to initialize the images. So with temp file, we're going to create a variable called images, which is going to hold our array of images. And we're going to convert from path our path. So this is /home/pi projects eReader PDF, and then the name of our PDF, which is actually quite long. I'm going to rename this to rpi.pdf just to make it a little bit easier to type here. So rpi.pdf is the name of our PDF. And let me close that. Next, we're going to set it to a DPI of 600 so that it has a better look and feel than the default of 200. It's going to slow it down considerably though. And we're going to select an output folder of path so that as it's reading these images in, it's saving them to disks to make the memory pressure less. We're going to create a tuple of 600 by 448, which is the resolution of this panel. And we're going to create a palette. Excuse me. The palette needs to be 256 colors long. We're going to specify the first 5 or 6, excuse me. We're going to specify the first 6 and leave the other 250 to black. So we'll start with white, and then we're going to do green. Then we're going to do blue, red, yellow, and orange. Then we're going to fill the rest of the array with zeros times 250 times 3. So we fill the rest of it with black. Next, we're going to create a p-image that is 1 by 1 size, and its color string is going to be 0 for now, because here we're going to put the palette in like that. Now, what is this for, you might ask? Well, I'm glad you asked. So what we're going to do is we've got these very big, gigantic pings, okay? And what we're going to do is we're going to first rotate the ping 90 degrees, because this is actually rotated 90 degrees here. And we're going to expand the canvas so that the rotation fills the new canvas. Then we're going to resize the image down to 600 by 448. And we're going to resample that with bicubic. Then we're going to convert it to RGB with a dithering pattern of Floyd-Steinberg. And finally, we're going to change the palette to this palette that we just created. And we're going to do that for each page. So let's do that. For page number, for page num in range length of images, we're going to loop over it and do this. So images at page num is going to equal images. We're going to take the existing page and we're going to modify it. So first we're going to rotate by 90 degrees and expand the canvas. And expand the canvas. Then we're going to resize the image to the panel size. And our resample is image.bicubic, just to make it look a little nicer. Then we're going to convert this to RGB. And we're going to dither it using Floyd-Steinberg. Finally, we're going to quantize it using a palette found in p-image. It's a lot, isn't it? Last but not least, we're going to return this images array. Okay, so now we've initialized the images, and this is the part that takes the longest. This takes about, on my tests, it takes anywhere from 15 minutes to an hour and a half, depending on that DPI setting. Next, we want to display a page. So let's define display page. And we're going to pass in the image that we want to display. And this code is taken pretty much verbatim from the example code that you can get for this e-reader, this e-paper module. So first we define a variable called EPD, which is the EPD 5" 65.epd class. We don't have to put these logging information in, but it sure is helpful when you're debugging to find out where things are happening. So up here on line 38, I'm going to add another one in. Like this, so that we know where we're at in this process. Okay, so next we want to, back down here on line 48, epd init, dot init, then epd dot clear. That initializes the epd display and clears the current display. Next, okay, logging info, display bitmap file. This is where we actually display the file, the image that got sent in. Instead of bitmap file, we'll just say image here. epd display epd.getBuffer and then image. And that's all there is to displaying an image on this ePaper display. So then we want to sleep, and we want to call dev exit. And then some debugging in case something happened when we were trying to display this information. And keyboard interrupt in case we press Control-C while it's displaying a page. And we exit out if that happens. Exit out of the app if that happens. Okay, so we've initialized the images and we've shown an image. Next, we want to listen for these two buttons here. This is the main loop of the app. Is these two buttons here, just listening for them to do something. So let's define a function. First, let's define our two buttons as home button being 21 and next button equals 20. Those are the pin numbers that those buttons are attached to on the Raspberry Pi here, 20 and 21. Well, not the pin numbers, they're the name of the pin. It's actually pins 40 and 38, I think. Okay, next let's set up the GPIO. Next, let's create a variable called homeState. And that's going to take the current input of the home button and we'll wait on this. So home state. So what happens here is we listen for these buttons, and when the buttons aren't being pressed, we're getting ones. So it's high. The voltage is high on this button. So when the button is pressed, the button goes to 0. So on the home button, which is this button down here, we're getting 1. So while true, we want to run this loop. And then if it's false when the button is pressed, then we'll break this loop. And you'll see the cleanup that we do in just a minute. Let's do that first, actually, so I don't forget. We clean up the GPIO and we return 0. Okay? Now, while we're in this loop, we want to do some work. So let's look at the next button. And the next button is GPIO input next button. And if that next button state equals 0, then we're going to do GPIO cleanup and we'll return 1. If that doesn't equal 0, then we're going to set the time and sleep for 1 second, for a quarter of a second. It's kind of short, makes this loop really fast, but it also means that we don't have to hold the button down for as long as a full second. Then we want to check the home state of GPIO input home button. And we do that at the end of the we do that at the end of this loop between while and home state. We check it every time we get to the end. We check it at the beginning, we check it at the end, so that we can know when to break this loop. We break this loop either if the next button state equals 0, we return 1 from this function, or we clean up and return 0. That's it for the functions that we need. Let's go ahead and initialize images. Images is equal to init images. Okay. Then we want to initialize by displaying the first page, page number, which starts out at 0. And then we're going to set a variable called run to be true. Okay? Oh. Run equals true. Sorry. What's this for? Well, we're going to have a loop. We're going to have an app loop. So while run, which is always true, except for in certain cases, then we want to say current state is equal to listen UI. Okay? So what this does is it listens for the UI. So the UI is going to block. Okay? It's going to block, and while home state is 1, we're going to wait for the next button to be pressed or the home button to be pressed. Okay? When one of those is pressed, then we return either 1 or 0 into current state. And we want to check that. So if current state equals 1, right? Then we want to increase the page number. So we want to check if page number plus 1 is greater, or excuse me, is less than length of images. Length of images. Then we say page number plus equals 1. Okay, that's just a little guard to make sure that we don't go beyond the end of the PDF file. Then what we want to do is we want to display the page, the new page. Else, if the current state isn't 1, then we just say run is equal to false. Okay? So again, current state equals listen to UI. So it blocks right here. Listen to UI runs this loop right here until either the home state button is pressed or the next button is pressed. Okay? If the next button is pressed right here, so if current state equals 1, next button, then we increase the page number and display the new page. Else, if the home button was pressed, then we would say run is equal to false and this main loop ends and we're out of the program. Pretty straightforward and simple, right? Let's go ahead and run it and see if it works. Okay, now we're running the file. Now remember, up here, we're initializing this convert from path. And this home projects eReader PDF RPy is really big. It's 200 pages long. I couldn't find a shorter one that looked good. And we're doing it at 600 DPI. So this will take a bit of processing time and power to get up and running. So I'm going to fast forward to the part where it starts processing the pages. Remember, we're going to render page here. We're going to log rendering page here. So when we see that down here, I'll return. And now it's done with the initial conversion of the PDF to images. And now we're going to do the conversion, the rotate, the resize, and the convert. So you can see we're rendering page 0, page 1, page 2. So this will take a little while to complete. Now that we've initialized all the images, we want to display page number 0. So before I hit play, I'm going to switch cameras so that we can view just what's happening here. So the Raspberry Pi will send the bitmap information to the display and it will be displayed. Let me click go. And now it will paint the image. And there's the cover page of the official Raspberry Pi handbook for 2021 on the Raspberry Pi 4. Now if we press this button, it will switch to the next page. And first it'll clear the display. and then it will paint the image. And now it's painting the image. There it is. There are obviously a few problems with doing this. The first is it's very slow to load the PDF. It took about 45 minutes to load a 200-page PDF in this way. And then it took another 5 to 10 minutes to massage each of those images into something that can be displayed on this e-paper module. The second thing that's a problem here is the speed at which it changes pages. Let's do this again. From the time I click the button until the time the page is ready, it's a painfully long amount of time. The colors aren't as rich as they would be on an LCD screen. And in fact, up close, the text isn't even readable on this display. If we said 1200 dots per inch, it would be a little bit clearer, but this text, this small text, still would not be readable. So what else could we do with this? We could also look at doing EPUBs, because EPUBs, the text is actual text, and we could put it on the screen as text. And that might be readable. And that might be something that we look at in a future video. If you're interested in seeing that, please leave a comment down below, and maybe I'll investigate that. Anyway, thank you for watching. This has been another Spectacularly thing, making an e-reader out of an e-paper module and a Raspberry Pi 4. If you enjoyed this video, please give it a thumbs up. If you didn't like this video, press the thumbs down button twice. And hit the subscribe button. It helps me out to know that there are people that were waiting to see new videos from me. So thank you, and have a great day. Bye.